Hello everyone, it's Wilson here. Today let's talk about finding a unit vector that is perpendicular to this vector ai plus 4j minus 6k. So you can actually just rewrite this as v is equal to 8 and then 4 and then negative 6. Okay, and so how do we do this? This one, for this problem, the answer is not unique. You can actually find different answers that will actually work. That is a unit vector that is also perpendicular to this vector. So in this video, I'm going to show you two ways that you can do this. So the first way is that, well, let me write it down. So approach 1. So we can actually just start with the first approach right here. Okay, so how do we do this? We can come up with a vector. So let's just call this vector that we're trying to figure out as let's say v1. Okay, and then we call this ABC because we don't know the answer yet, right? So just call them ABC, and then what we do is that we are going to take this vector v1 and then take the dot product of this v, so dot them, right? So what happens is that we are going to just do v1 dotted with v, and that means we are going to get A and then B and then C dotted with 8, 4, and negative 6. And if they are perpendicular, then what happens? They're supposed to be giving you a dot product that will be 0. Okay, so what happens is that if you take the dot product, you should be getting 0. So those two vectors are perpendicular to each other. So now what happens is that if you compute this dot product right here, then we are going to get AA plus 4B and then minus 6C is equal to 0. And then so you may say, how do we come up with the answer? Because this is an equation with 3 unknowns right here. And as I said, it doesn't really, we don't really have like a unique answer here. So that means we can actually just pick some numbers for ABC and then just make sure that we can find a set of ABC that will satisfy this equation. So the easy way to just to look at it is that the A and the 4 we can just pick. We can pick something like let's say we pick A to be 1 and then B to be 1. Okay, so that means you're just adding the A and the 4. We get 12. 12 minus 6C is equal to 0. So C must be what? In this case, the C will be what? Must be 2. So we actually come up with the answer for V1 already, right? So what is V1? Then that gives us that V1 is actually equal to 1, and then 2. Okay, so that's the vector that is perpendicular to this V here. Okay, because it comes from this equation. Now, then you may say, what's next? The next step is that we just want to find the unit vector, and that is actually really simple. We just take this vector and then multiply by the reciprocal of its magnitude. So the idea is really simple. So we just find the answer as V1 over magnitude of V1, and then we have the answer. So we are going to just get 1, 1, 2, and then divide by its own magnitude. And so we are going to get 1 square plus 1 square plus 2 square. And so what do we get here? We are going to get 1, 1, 2, and then in the denominator, we are going to, let's see, so this is 1, this is 1, this is 4. So we are going to get 1 plus 1 plus 4. So we get 6. So we get the square root of 6 as the denominator. And then we can now just write down the answer. So one answer that we are getting is 1 over square root of 6, 1 over square root of 6, and 2 over square root of 6. And this is a unit vector, okay? And that is also perpendicular to the given vector v. Okay, so that's approach 1. That's one way that you can do it. This requires you to just pick some numbers, and then that will satisfy this equation, and then you can come with the answer. And if you don't like that, let's say if you don't feel like picking numbers, then here is another way to do it. So what happens is that I'm going to show you a second way to do it. And so right now we are going to just talk about approach 2. Okay, and then you may say, how do we do approach 2? The approach 2 is it's to use the idea for the cross product. And then you may say, why do we suddenly use the cross product? Because when you take the cross product of two vectors, that resulting vector is perpendicular to the vectors that you are crossing. So now what happens is that then you may say, we don't have another vector, right? Because we only have the v here. The v is, let's write it down again. This v is actually just 8, 4, -6. Now you may say, how do we cross the, how do we get a cross product because we don't have another vector? So we can actually just come up with some random vector here. So when I say random, it actually basically can be anything, but then just make sure that you don't choose the 0 vector here. So what we can do, okay, is that we can just pick a random vector, just pick a random vector. What do we have here? We can just call this r. And then what is this vector here? We can just pick the easiest one. We can just pick I, which is 1, 0, 0, right? So you can just pick the unit vector I, okay? And then we just take the cross product of the v and the I, okay? So what happens is that we can just take the cross product. And then, so here's what we do. We write them down. So we get 8, 4, -6. And then we also have the vector 1, 0, 0. Okay, so now what? Now just compute, right? So we have crossing out the first row, first column, then we are going to get this 2 by 2 determinant right here, the 4 times 0, and then 0 times 6. We just get 0 for the first component, so that's easy. Now crossing out the first row and then the middle column, then we are going to get 8 times 0, we just get 0, and then 1 times -6, and then we get -6. But then we got to subtract this 1 times -6, right? We are going to get +6 here, but then we still going to negate the middle component here. So we are going to just get -6. Yeah, so we're just going to get -6. And then the last component, then crossing out the first row and then the last column, then we're going to get this 2 by 2 determinant right here. So 8 times 0 is 0, 1 times 4, we get -4. So this is the vector that is perpendicular to both v and r. And actually the r we don't really care about too much. We only care if it's this vector, it's perpendicular to this v, and in fact it is, right? Because it's the cross product of v and r, so it's going to be perpendicular to v. And so now we already get the vector, okay? And now what happens is that we can find its magnitude and then divide by its magnitude, then we can actually just get the unit vector that is perpendicular to the v. So how do we do it? We can actually call this one v2, and then that's another answer that we can get for this problem. So we are going to get v2 over v2 over the magnitude of v2. So we are going to get 0, -6, 4 in the numerator, and then the square root of 0 square plus -6 square, and then plus -4 square. And then we are going to be getting what? We are going to be getting 0, -4, and then 4 at the top. So that stays the same, right? And then we are going to be getting, well, let's see. So this one is 36. This is, well, let's actually just write it down here. So this one is 36, and this one is 16. So adding the 36 and the 16 together, we are going to get 52. Okay. And then, so as you know that the 52 can actually be broken as 4 times 13. So the 4 is the perfect square, so you're just going to get a 2. So we are going to get 0, -6, and then 4. And what do we get at the bottom? We are going to get 2 square root of 13, as you can see. And then we are just simplifying this, then we get the answer. So we just need to do what? We are just going to just distribute this into each component here. So the first component is still 0, and then 6 divided by 2, we get -3 over the square root of 13. And then 4 and the 2 cancel out. So we just get the 2 over the square root of 13. And in fact, I just realized that I was missing a negative sign right here. So this is -4, this is negative. And so let me just fix that. So this is -4. And then a lot of fixing right here. But then... And then this one is a -2. Then we're good. Yeah. So that's it for this problem. And as you can see that this vector that we are getting here, if you just go back up to look at this one, they are not scalar multiples of each other. That means what? That means they are not parallel to each other, yet they are both perpendicular to this v. As you can see that the answer is not unique. You can actually find more answers that will work. And so tell me which approach that you like better, okay? And then I will see you next time.